I'm going to look up a z-score of negative 2.98. Just right here. So negative 2.98. The area to the left of that z-score is 0.0014. And that's my p-value because this is a left-tailed test. And now I'm going to compare it to my alpha right here in step 6. So step 6 is to accept or reject the null. And step 7 will be to accept or reject the claim. So let's talk about when you do what. To reject the null, your value would need to be smaller, in this case, smaller than 0.01. You see how this is a smaller area than 0.01? So you imagine if I made this into a z-score, like 2.98, it'd be much smaller. It would fall in this rejection region. So I'm going to write a little key over here. If p is less than alpha, less than or equal to alpha, actually, you reject the null. And if p is greater than alpha, you accept the null. Pause if you need to. Okay, let's see, I've got p on the left. So p and alpha. P is 0.0014 and alpha is 0.01, and that is less than that. And since p-value is less than alpha, I'm going to reject the null. And then for step 7, I have to decide whether I'm going to accept or reject the claim. Let's see, I'm rejecting the null, which means that I must be accepting the claim. And my sentence is that, let's see, I accept the claim that the pit crew crew's mean pit stop time. Uh-oh, my pen's running out. Is less than 13 seconds. Man, that's fast. Very cool, though. All right. Alas, goodbye, dear pen. You were amazing. Okay, I totally got that in the garbage, and you can't see, but I swear it's true. This is a new pen. This is purple, not the same pen. You don't believe me, but it happened. It really did happen. Stop not believing me. Stop it. You guys, you never believe anything I say. All right, you're going to try example 7 now. If you feel comfortable. If you're like, I still don't know what I'm doing, and I just want to follow along with her, feel free to watch and follow along with me. If you want to try it yourself first, then go ahead and go for it. Even if you can try just like half the problem and then continue, that'd be great. I'm not going to flip back and forth anymore between my directions. You can, but I'm not going to because I teach this class, so I don't need to. And I wrote these directions, so I think I can figure it out. Make sure that if you can try it yourself that you do, but if you need some more help, then feel free. Okay, so starting with number 1, it says, according to a study, the mean cost of bariatric weight loss surgery is $21,500, and you think this information is incorrect. So you randomly select 25 bariatric surgery patients and find that the mean cost for their surgeries is $20,695. From past studies, the population standard deviation, that's the word I wanted to see, is known to be $2,250. It also says that it's normal here, so it's normal. Awesome, we can do this problem. Step 2, H sub O, H sub A. All right, the claim, it looks like our claim is that, I mean, you could really do this two different ways. You could say that the claim is that the surgery is this, or you could say your claim is that you are saying that it isn't that. Let's do that. So the mean cost of the surgery isn't $21,500. That's our claim, because we're claiming that it's wrong. But really, it wouldn't matter. Like, if you had this question on a free response question on an AP test, and you decided to call the claim what they're saying that the weight loss surgery is $21,500, it wouldn't matter, because at the end, if you have a sentence, then they're going to know what you're talking about, so it doesn't really matter. Mu is equal to 21,500. Remember that I'm choosing to do this here because it's not equal to, which has to be the alternative. Step 3 has me draw a picture. This one is going to be a two-tailed test. That's because it's an equals to problem. H sub O is in the middle. Remember, I'm not going to actually figure out the z-scores here. I'm just going to be comparing them to alpha. Okay. Alpha in this case is 0.05. The only reason I know it's a two-tailed test is because it's an equals to problem. Next thing I'm going to do is find a z-score, x bar minus mu over sigma divided by the square root of n. Make sure you got your parentheses in there. That is equal to, in this case, let's see, I randomly select this many, there's my n, the mean cost, that's my x bar, so 20,695 minus my claim, 21,500, divided by sigma 2250 divided by the square root of 25. $20,695. All right, negative 1.79 is my z-score, but I'm not going to compare it to that because that's how you do it with rejection regions. Actually, people don't even usually draw a picture when they're comparing p-values to alpha. And if you're wondering why would we use p-values since rejection regions is so easy and we already understand it, often computer programs, when they're doing like hypothesis testing, there's lots of computer programs out there that will do the math for you, and then they come up with a p-value at the end.